Cretaceous forests are usually shown as lush, vibrant, postcard-worthy paradises. The geology, pollen records, and trace fossils tell a very different story. Living in the Cretaceous was a slow, daily, low-grade horror that filtered every minute of every life that passed through it. We are talking about a world with atmospheric oxygen hovering near 32%, turning every lightning strike into a catastrophic firestorm. There was no grass anywhere, not a single blade. The undergrowth was dominated by toxic ferns. The air itself was a weaponized soup of biting flies carrying ancient strains of leishmania and malaria, and giant fleas the size of your thumb drained blood at industrial rates. This was not a gentle paradise. This was a beautiful, exhausting, terrifying place to be alive, and we have the mummified skin and infected bones to prove it. For decades, we have painted the Cretaceous as a gentle world of towering conifers and serene giants, a planet-wide dinosaur spa where nothing really went wrong except the occasional asteroid. The fossils tell a much bleaker truth. Paleontologists have uncovered mummified skins scarred by tooth and claw, the bones of 100-ton sauropods riddled with parasitic lesions, and coprolites so packed with intestinal worms they read more like a horror novel than a scientific sample. The dirt itself is full of charcoal, layers of it, because in a world where the air held nearly half again as much oxygen as you are breathing right now, fire was not an occasional visitor. It was a season. Every lightning bolt turned acres of forest into a furnace, and the creatures that lived here breathed particulate smoke from the day they hatched. There was no grass to cushion a fall, no soft meadow to rest in. The forest floor was a tangle of toxic ferns, rotting vegetation, and standing water that bred mosquitoes carrying ancient strains of malaria and leishmania. Giant fleas with bodies the length of your thumb worked in shifts, and the humidity, a permanent 80%, made every wound a fungal breeding ground. The question is not how the dinosaurs died. The question is how any of them lived long enough to grow up at all. Because the real challenge was not the tooth you could see. It was the billion microscopic enemies you never saw coming. So take a breath, but not too deep. Right now, you are not just learning about the Cretaceous. You are about to enter it at ground level. Welcome to the forest. You are standing in the understory now. The first thing you notice is the light. Not the golden shafts you see in paintings, but a sickly green half-dusk, filtered through a ceiling of conifers and ancient ginkgos that block all but a few struggling rays. The heat wraps around you like a second skin, wet and clinging, because the humidity here hovers around 80%, day and night, season after season. Nothing ever truly dries. The air is so thick with moisture that you can almost feel it condensing in your lungs, and with every breath you inhale more than just water vapor. You inhale the particulate smoke from fires burning somewhere over the horizon, fires that have been burning for weeks and will continue to burn until the next rain, and the next rain is never guaranteed. This is the Cretaceous atmosphere, a recipe for catastrophe that scientists have only recently begun to decode. But here is the thing no textbook told you. The oxygen level in this air is sitting somewhere between 25 and 32%, compared to 21% today. That number sounds small, but its consequences are enormous. Fossilized tree resin, amber from the Cretaceous, has trapped tiny bubbles of ancient air. When researchers analyzed those bubbles, they found oxygen concentrations that would make modern lungs dizzy. At 32%, you are not just breathing easier. You are living in a tinderbox. Every bolt of lightning that strikes these conifers does not just singe bark. It triggers a conflagration that can race across hundreds of miles, consuming everything in its path, and the fossil record is full of the evidence. Charcoal layers are so common in Cretaceous sediments that geologists now call this period a high-fire world. The forests did not just burn occasionally. They burned constantly, in cycles of destruction and regrowth that shaped the very DNA of the plants that survived. Now look down at your feet. This is where the real dissonance begins. You expect to see ferns, yes, and maybe some low shrubs, but you also expect grass. Every modern forest floor you have ever walked on, every depiction of dinosaurs in film, instinctively paints the ground green with soft blades. Grass did not exist here. The first true grasses would not appear for millions of years after the last dinosaur collapsed. What you are standing on instead is a mat of fallen gymnosperm needles, rotting cycad fronds, and sprawling ferns that do not cushion your step. They bite. Many of these understory plants are loaded with toxins, alkaloids and tannins designed to make them as unpalatable as possible. Because in a world where everything gets eaten eventually, chemical warfare is a plant's only defense. Every mouthful of this undergrowth is a gamble between nutrition and poison, and the ground beneath the fronds is not soil as you understand it, but a thick, damp sponge of decaying matter, crawling with organisms that accelerate rot to speeds you would not believe. And that decay is not passive. It is an active, hungry force. In this constant tropical humidity, dead things do not mummify on their own. They dissolve. Bacteria and fungi work in overdrive, breaking down fallen logs, shed skin, and carcasses with an efficiency that modern ecosystems cannot match unless you are in a rainforest. The smell is not the pleasant petrichor of a modern woodland. It is the rich, almost sweet stench of rapid decomposition, the faint sulfurous tang of anaerobic mud, and the acrid note of distant smoke. Standing here, you begin to realize that the forest is not just a backdrop for the dinosaurs. It is an adversary. Every organism that walks, crawls, or breathes in this environment is in a constant arms race with rot, with fire, and with the invisible swarms that fill the air. But before we go further, you need to understand something about the creatures that ruled this world. They were not immune to any of it. The skeletons we mount in museums, the towering titanosaurs and the terrifying theropods, those bones carry the scars of a lifetime spent fighting this environment. In a lab in Brazil, researchers recently cut into the fossilized bone of a titanosaur that lived in the late Cretaceous. What they found stopped them cold. The bone's vascular canals, the microscopic channels that once carried blood and nutrients, were packed with the fossilized bodies of parasites, tens of them. The dinosaur had suffered from acute osteomyelitis, a brutal bone infection that would have caused chronic pain, fever, and eventually immobility. This was not a sick animal on the fringes of a herd. This was a giant that should have been untouchable, brought low by enemies too small to see. And the titanosaur was not an outlier. Coprolites, fossilized feces from the early Cretaceous of Belgium, have yielded protozoan cysts and helminth eggs from animals that lived alongside Iguanodon. 3 different phyla of parasites were infecting dinosaurs by this point in history. 3. They had roundworms, flatworms, and single-celled pathogens that caused dysentery. Imagine being a multi-ton animal and spending your days with your guts in revolt, losing fluids you could not easily replace, weakening while the world around you demanded constant vigilance. That is the reality the fossil record paints, and it gets worse. The skin tells its own story. In China, a specimen of Psittacosaurus was preserved in such extraordinary detail that researchers could study its cellular structure. The dinosaur had patches of scaly reptilian skin and patches of feather-like structures, a transitional armor that scientists now believe served multiple purposes. One of those purposes, perhaps the most critical, was parasite defense. Developing specialized skin was not just about thermoregulation or display. It was about creating barriers against the relentless assault of biting organisms that bred in every puddle, every damp crevice, every inch of exposed flesh. In North America, mummified hadrosaur skin shows tooth marks from scavengers that fed on the carcass, but also older, healed scars, evidence of injuries and infections that the animal carried for years before it finally died. Living in the Cretaceous meant accumulating wounds the way a tree accumulates rings. Every scar was a chapter in a biography of daily assault. But the true masters of this world were not the dinosaurs. They were the insects that fed on them, and the Cretaceous saw an explosion of blood-feeding innovation that would make a modern entomologist dizzy. The fossil record from this period preserves a catalogue of parasitic nightmare. There were mothflies and Corythrilidae, midges, swarming in the damp understory. There were biting midges and black flies that targeted the soft tissues around eyes and mouths. There were snipe flies and horseflies with mouthparts designed to slice through even the toughest hide and drink what flowed out. And there were mosquitoes. Not the quiet, almost delicate creatures you swat away at a summer barbecue, but robust, persistent blood feeders that had already begun to evolve the relationship with disease that would eventually make them the deadliest animals in Earth's history. Some of these mosquitoes fed on dinosaurs, and some of them carried pathogens. In amber from the Cretaceous, scientists have found biting insects preserved with the organisms that cause leishmania still in their guts. Leishmania is a brutal parasite that infects reptiles today, causing skin lesions, organ damage, and often death. Another insect was found carrying primitive malaria organisms related to strains that infect modern birds and lizards. George Poinar, the parasitologist who has spent decades studying this material, put it starkly: the associations between insects, microbes, and disease transmission were just emerging in the late Cretaceous, and the world was covered with warm, temperate, to tropical areas that swarmed with infected biters. The dinosaurs were walking through clouds of these vectors every day, from the moment they hatched until the moment they collapsed. But what did that actually feel like? What did it mean to be a living dinosaur in this world, day after day, season after season? Let us start at the beginning. You are a hatchling, small enough to be stepped on, soft enough to be eaten by anything with a mouth. Your skin is thin and your immune system is naive. Within hours, you are discovered by the first biting flies. They settle in the corners of your eyes where the moisture gathers, the softest, most vulnerable skin on your body. They drink, and as they drink, they leave behind the pathogens that will multiply in your bloodstream for the rest of your life. You cannot swat them away because you do not have hands. You can only blink, shake your head, and hope. The hope is rarely enough. As you grow, you learn that the forest floor is not safe. The toxic ferns teach you that lesson early, punishing any exploratory mouthful with nausea or worse. You learn that the standing water in the hollows of fallen trees is not for drinking unless you want a fresh dose of protozoan cysts. You learn that the carcass of a dead animal is a banquet for some, but a minefield of intestinal parasites for the unwary. And always there is the smoke. The fires that sweep through the dry season reshape the landscape in hours, forcing entire herds to flee through terrain they do not know, toward water sources that may already be claimed by competitors or predators. In a high-fire world, migration was not a seasonal choice. It was a sudden, desperate scramble that happened again and again until luck ran out. The larger you become, the more you attract attention. Not just from predators, but from the large blood feeders, the fleas. Pseudopulex magnus is not a name that rolls off the tongue, but it should strike fear into anyone who imagines a gentle Mesozoic. This creature was a flea the size of a human thumb, nearly an inch long. It did not hop harmlessly in the leaf litter. It burrowed into the skin of dinosaurs, anchoring itself with mouthparts that could pierce even the thick dermis of a large sauropod, and it fed. The itching would have been maddening. The secondary infections from the wounds would have been constant, and fleas were not solitary. They bred in the nests and bedding areas where dinosaurs slept, which meant that sleep itself became a vector for blood loss and disease. But here is the part that fossils struggle to tell us, and where the science becomes almost too vivid to bear. The psychological toll. We have all experienced a single mosquito in a dark room, a single buzzing note that keeps us awake. Now multiply that by millions. Imagine a soundscape that was not just the calls of distant hadrosaurs, but the constant, inescapable whine of biting insects. Imagine resting against a tree trunk and feeling not just the bark, but the tickle of a dozen questing ticks, ancient arachnids that had already evolved the patience to wait for months for a host to brush past. Imagine the exhaustion of never being truly still, never fully at rest, because the moment you stopped moving, the swarm descended. And we know this because the parasites did not just infest dinosaurs, they shaped their evolution. The elaborate crests of hadrosaurs, the frills of ceratopsians, the plates of stegosaurs, these were not just for show or for combat. They were vascular, rich with blood vessels, capable of flushing with color or radiating heat. They were also prime targets for biters. Every evolutionary solution to the insect problem created new vulnerabilities, and the insects adapted in turn. This was a Cold War that lasted over 100 million years, and the dinosaurs were always on the defensive. But the final, crushing weight of the Cretaceous environment was not just biological. It was chemical. The oxygen-rich atmosphere that made wildfires so catastrophic also had a direct effect on every living lung. Breathing high oxygen air over a lifetime causes oxidative stress at the cellular level. Tissues age faster. DNA damage accumulates. The dinosaurs did not know it, but they were breathing a slow poison, even as they dodged the faster poisons of parasites and fires. Their lungs were being quietly scarred by the very air that allowed them to grow to such monstrous sizes. The trade-off was invisible, but it was relentless. And now we come to the heart of the matter. The fossil record of the late Cretaceous is not the story of a thriving world at its peak. It is the story of a world under siege by forces too numerous to count. The extraordinary diversity of dinosaurs we celebrate is not evidence that the system was healthy. It is evidence that evolution was throwing every possible adaptation at a set of challenges that never relented. For every tyrannosaur that dominated the landscape, a billion parasites dominated the tyrannosaur. For every armored herbivore that seemed invincible, the smoke from 1,000 fires slowly poisoned its lungs and shortened its life. This was not a gentle dying. This was a grinding, exhausting attrition that began on the first day of life and did not stop until the last breath. So when you picture the Cretaceous, do not picture a peaceful giant ambling through a sunlit glade. Picture a massive bull triceratops, horned and frilled, a walking fortress of bone and muscle, standing in a forest clearing at twilight. The smoke from a distant fire blurs the horizon. His skin is scarred and weeping from fungal lesions that will not heal. His eyes are crusted with the dried residue of 100 fly bites. Inside his guts, a colony of nematodes is slowly stealing his nutrients. He is magnificent, and he is tired. He has been tired for as long as he can remember. The next chapter belongs to the tiny things, and in the end, they always win. The Triceratops stood breathing smoke and pain, but he was not alone in his suffering. The Cretaceous was a world engineered to test every limit of biology, and the tiny things did not wait for the asteroid. They worked in shifts around the clock, from the moment the first dinosaur egg cracked open in the nesting grounds. To understand why the forest was a slow-motion horror, you need to start with the air itself, because the atmosphere was not just a passive blanket. It was an active agent of destruction. Fossilized amber from the Cretaceous has yielded tiny bubbles of ancient atmosphere, perfectly sealed for millions of years. When scientists cracked those bubbles open and measured the oxygen content, the numbers were staggering. 30%, sometimes closer to 32%. That is nearly half again, as much oxygen as you are breathing right now. At first glance, that sounds like a gift. More oxygen means more energy. It is why dragonflies with 2-foot wingspans could zip through the Mesozoic air, and why some dinosaurs achieved body masses that seem to defy biomechanics. But hyperoxia, as it is called, comes with a hidden price. Oxygen is reactive. It rusts metal, it spoils fruit, and inside a living body, it slowly burns tissues at the molecular level. Every breath a dinosaur took was a tiny oxidative hit, a spark of cellular damage that accumulated in their lungs, their blood vessels, and their mitochondria. They did not feel it, the way you do not feel your cells aging, but it was there. The great sauropods that could eat from the tops of trees were also breathing themselves old faster than any animal that had come before. But the real danger of 32% oxygen was not invisible cellular stress. It was fire. In a world with this much oxygen, combustion is not a threshold you meet only in dry lightning storms. It is a permanent possibility. A single spark from a rockfall, a lightning strike, or even the intense heat of a volcanic vent could ignite the resin-rich conifers and the deep mats of dried fern fronds. Once lit, a Cretaceous wildfire did not creep across the forest floor the way modern fires do. It exploded. The research on charcoal layers in Cretaceous sediments tells a terrifying story. From the Valanginian onward, spanning tens of millions of years, the fossil record is packed with charcoal. Not occasional streaks, but thick, continuous bands. Some researchers describe the Cretaceous as a high-fire world, where fire was not a disturbance, but a regular, ecological force, as constant as the rain in a modern rainforest. Entire landscapes were shaped by burn cycles that returned every few decades, sometimes every few years, depending on the region. Imagine you are a nestling hadrosaur, less than a month old, and the air begins to taste acrid. The adults in your herd lift their heads and begin to move, not with the casual browse of a lazy afternoon, but with a sudden, urgent purpose. The sky, already filtered to a dim green through the canopy, turns a bruised orange. The wind shifts, and the sound reaches you. Not just the crackle of burning wood, but a roar, a deep, continuous, hungry roar that is louder than the largest predator you have ever heard. The fire front is not a line. It is a wall, moving at speeds that can outpace a running hadrosaur, and it consumes everything. The oxygen feeds it like a bellows. Conifer trunks, heavy with sap, burst into torches. The understory ferns, dried by weeks without rain, vanish in sheets of flame. The heat is so intense that it creates its own weather, sucking in air from all directions and flinging burning debris miles ahead of the main front. Any animal caught in the path had seconds to react. The fossil record shows that not all of them made it. In some bone beds, paleontologists find the remains of dozens of dinosaurs piled together, not killed by predators, but trapped by fire. The charring on the bones is unmistakable. These animals did not die peacefully. They died in panic, in smoke so thick it blinded them and seared their lungs before the flames ever touched their skin. And the ones that escaped did not escape unharmed. They ran through burning undergrowth, scalding their feet and legs. They inhaled superheated air that blistered their airways. They stumbled into rivers and lakes where they were safe from the fire, but exposed to the next wave of threats, drowning crocodilians and the shock of sudden cold after extreme heat. After the fire passed, the world that remained was a blackened wasteland. The leaf litter was gone, leaving behind only ash and the charred skeletons of trees. The understory that had provided food and cover was ash. The steady supply of ferns, cycads, and low-growing angiosperms had vanished, and with it, the base of the food web. Large herbivores faced starvation within days if they could not reach an unburned patch. Small animals, the mammals, lizards, and amphibians that had survived by burrowing or sheltering under rocks, emerged into a world stripped of cover where predators could see them from hundreds of feet away. The fires did not just kill directly. They reset the game board, forcing every survivor into a brutal lottery of starvation and exposure. But even in the absence of fire, the forest itself was chemically hostile. The plants of the Cretaceous were not passive salad bars for hungry herbivores. They fought back with chemistry that would make a modern botanist wince. The dominant ground cover was not soft grass, which had not evolved yet, but ferns, cycads, and early flowering plants that loaded their tissues with alkaloids, tannins, and other secondary compounds. Ferns of the order Cyathales, the tree ferns that formed the understory in wetter regions, produced carcinogenic toxins. Some cycads concentrated neurotoxins that could cause paralysis in animals unwise enough to eat too much. The angiosperms, the new kids on the evolutionary block, were experimenting with latex, resins, and bitter terpenoids. Ankylosaurs and ceratopsians evolved complex dental batteries to grind through this fibrous, toxic material, and their guts must have been vast fermentation chambers. But even so, the cost of eating was a constant, low-level poisoning. A young dinosaur, learning what to eat, made mistakes, and those mistakes could be fatal. Then, there was the rot. The humidity that kept everything damp also kept everything decaying. Fallen logs did not dry out and harden. They turned into red, fibrous sponges of fungal mycelium within weeks. The forest floor, thick with plant debris, was a mat of active decomposition, releasing methane, carbon dioxide, and a cocktail of volatile organic compounds. Any wound, any scrape on a dinosaur's leg from tripping over a root became an entry point for fungal spores. In a modern environment with low humidity, a wound might dry and scab. In the Cretaceous, it rarely dried, it festered. The mummified hadrosaur skin from North America that shows healed scars also shows the signs of chronic low-grade infection, thickened tissues and pitted surfaces that suggest the animal fought off skin infections repeatedly in its lifetime. And those were the lucky ones that healed. For every healed scar, there must have been dozens of infections that went systemic, killing the host through septic shock or slow organ failure. Now let us return to the insects. I told you about the mosquitoes and fleas, but that was only the beginning. The Cretaceous was the golden age of blood feeding, and the diversity of mouthparts that evolved to puncture dinosaur hide is genuinely staggering. Picture the daily existence of a sauropod, a massive Alamosaurus moving through a forest edge at dawn. Her head is so far from the ground that she cannot see the horde rising from the damp understory, but she can feel it. First, the black flies find the thin skin around her eyes and nostrils. Their mouthparts are not delicate. They are serrated, designed to saw through epidermis and lap up the blood that pools. The sauropod blinks, shakes her head, but the flies are persistent. Next, the horseflies arrive, larger, more robust, their bite so sharp it can pierce even the thickened hide of her flanks. They target the areas where blood vessels run close to the surface, the armpits, the groin, the belly. Each bite leaves a small, weeping wound. But the most insidious attackers are the ones that do not just feed and leave. The Cretaceous was warm enough to support ticks, large, leathery arachnids that climbed up fern fronds and waited for a host to brush past. When a tick finds bare skin, it anchors itself with barbed mouthparts and cements its attachment with a secretion that makes removal nearly impossible. A single sauropod might carry thousands of ticks, embedded in the soft skin between scales, around the ears, under the tail. Each tick is a potential vector for blood-borne parasites. And the fleas, the giant, thumb-sized fleas, did not just suck blood. They burrowed. They created subcutaneous tunnels where they could feed, breed, and lay eggs, causing intense localized inflammation. The itching alone would have driven an animal to scrape itself against rocks and trees, opening new wounds that attracted more flies and more infection. The disease load these vectors carried is just beginning to come into focus. The amber specimens analyzed by George Poinar and his colleagues are like time capsules of Cretaceous pathology. One biting midge, perfectly preserved, was found with the flagellated protozoan that causes leishmania swarming in its gut. In modern reptiles, leishmania produces skin ulcers, weight loss, and organ failure. Another insect, a sandfly, was carrying forms of malaria that today infect birds and lizards. Malaria parasites invade red blood cells, bursting them in synchronized cycles that cause waves of fever and anemia. A dinosaur infected with malaria would have been weak, lethargic, and easy prey. The vectors did not just annoy. They delivered death, slowly, one bite at a time. But the parasites did not need a flying vector to spread. Many were transmitted by simple contact with contaminated ground. The coprolites from Belgium, the fossilized feces of early Cretaceous dinosaurs, contain a veritable zoo of parasitic eggs and cysts. There were trematode eggs, indicating flatworm infections of the liver and intestines. There were nematode eggs from roundworms that would have crowded the gut, stealing nutrients and causing blockages. There were protozoan cysts, likely from gut parasites that caused chronic diarrhea. In a modern animal, a heavy parasite load leads to poor growth, weakness, and increased susceptibility to other diseases. In a dinosaur, the same would have been true. A young dinosaur with a belly full of worms could not put on weight fast enough to outgrow predators or survive the lean season. The nursery herds were not just raising babies, they were reservoirs of parasitism, spreading infection to every new hatchling through shared nesting grounds and accumulated waste. And the parasites did not stop at the gut. The Brazilian titanosaur with the fossilized bone infection is one of the most extraordinary paleopathological discoveries ever made. The researchers who sectioned the bone expected to see signs of old age, maybe arthritis. Instead, they found tiny, round structures packed inside the vascular canals. These were fossilized parasites, likely blood-borne protozoans similar to the organisms that cause malarial-type diseases. The parasites had triggered a massive inflammatory response, osteomyelitis, that had turned the bone into a swollen, pus-filled abscess. The dinosaur was elderly, a senile individual, but it did not die of old age. It died in agony from a systemic infection that modern medicine would struggle to treat, even with intravenous antibiotics. Without treatment, the condition was a death sentence, preceded by weeks or months of escalating pain. Every step that Titanosaur took would have been torture, and yet it kept walking until it could walk no more. This is the point where the narrative shifts, because the old assumption was that dinosaurs were evolutionary superheroes, too big and too tough to be brought low by something as mundane as a parasite. The new evidence says the opposite. They were ecosystems. Every dinosaur was a walking host to dozens of species of internal and external parasites, and these parasites shaped their evolution in ways we are only beginning to appreciate. The elaborate cranial ornamentation of hadrosaurs, the crests that looped back over their heads in hollow, resonant tubes, were once thought to be purely for vocalization or display. Recent histological studies show that these crests were highly vascularized, packed with blood vessels that could transport heat. What if they were also designed to flush blood through exposed areas where parasites could be detected and removed by cooperative grooming? The frills and horns of ceratopsians, the plates and spikes of stegosaurs, these were not just weapons. They were radiator panels, but also areas where parasites could concentrate, where an animal could scrape against a tree or a herd mate to dislodge the ticks and fleas that accumulated in those high blood flow zones. But cooperative grooming only works if you have a social structure that allows it, and not all dinosaurs lived in herds. Solitary theropods, the large predators, faced the parasite problem alone. A Tyrannosaurus rex had no herd mate to groom the ticks from the folds of its neck. It could rub against rocks, but the most sensitive areas, around the eyes, inside the mouth, around the cloaca, were unreachable. theropods likely suffered from chronic eye infections from the biting midges that specialized on those tissues. Their gums may have been infested with leech-like parasites that fed on blood. The famous Sioux specimen, one of the most complete T. rex skeletons ever found, shows lesions on the jaw that some researchers interpret as evidence of a chronic parasitic infection of the mouth, possibly trichomoniasis, a disease that in modern birds causes caseous lesions in the throat and jaw, leading to starvation. Sioux did not go down fighting another tyrannosaur. She may have been slowly killed by a microscopic parasite that lodged in her throat and made swallowing impossible. The pivot here is brutal. We have imagined the Cretaceous as a world of titanic battles, of tooth versus claw, where the strongest jaws determined the future of species. The fossil record says the real battles were invisible, fought at the microscopic level, and the dinosaurs were losing them for millions of years before the asteroid ever appeared. The parasites, the biting insects, the fungi, the bacteria, these were the true apex predators of the Mesozoic. They did not need size. They had numbers, and they had evolutionary time on their side. A single female mosquito could lay hundreds of eggs. A single flea could produce thousands of offspring in a nesting season. The parasites multiplied faster than any dinosaur could adapt, and they evolved counter-adaptations at a pace that no vertebrate could match. And this relentless parasitic pressure may explain something that has puzzled paleontologists for decades: the strange, thin-skinned vulnerability of many large dinosaurs. Sauropods, for all their size, had skin that was in some areas surprisingly thin and delicate, as revealed by the rare skin impressions we have. Some researchers have speculated that the skin was thin to facilitate heat loss, preventing giant bodies from overheating. But thin skin is a terrible defense against insects. The trade-off would have been brutal. A sauropod that evolved thicker skin might have cooked itself internally on a hot Cretaceous afternoon. One that kept thin skin survived the heat, but succumbed to the constant drain of blood loss and infection. Evolution was pushing and pulling these animals in opposite directions, and there was no perfect solution. Every adaptation was a compromise, and every compromise had a cost that accumulated over a lifetime. Now, consider the cumulative effect of all these pressures on a single dinosaur's life. You hatch from an egg in a colonial nesting ground, surrounded by the feces of hundreds of adults, a soup of parasite eggs. Within your first day, you ingest nematode larvae. By the end of your first week, you are shedding parasite eggs yourself, reinfecting the nest and your siblings. Flies bite your eyelids and transmit blood parasites. As you grow, the oxygen-rich air scars your lungs. Wildfire smoke chokes you repeatedly, leaving you with chronic respiratory damage. You survive one fire, two fires, each time losing weight you cannot afford to lose. The ferns you eat are toxic, and you learn which ones are safe through trial and error, accumulating liver damage along the way. A tick buries itself in your ear, and the resulting infection swells your lymph nodes. You are weak, you are tired, and you are not yet half grown. And then the predators come. Not the great killers, but the small ones. The mammals that hide in the leaf litter have learned that dinosaur hatchlings are a reliable food source. They are fast, they are clever, and they are multiplying in the shadows of the giant reptiles. The snakes are emerging, evolving venom that can paralyze small prey in seconds. The crocodilians in the rivers are always watching the drinking spots. The pressure from below is as constant as the pressure from above. Every trip to the water's edge is a gamble. Every night spent sleeping on the ground is a risk. There is no truly safe place. The forest is alive with hunger, from the microscopic to the monstrous, and it all flows toward the same end. But here is the most overlooked terror of all. The Cretaceous was not just a gauntlet of parasites and predators. It was a world of constant, low-grade sensory assault. Modern animals rely on clear signals, a rustle in the grass, a scent on the wind. In the Cretaceous forest, the signals were buried in noise. The air was thick with the drone of insects, a sound so pervasive that it probably formed a constant background hum day and night. The smell of decay, smoke, and the musk of countless animals mixed into a confusing olfactory soup. A young dinosaur trying to detect a predator by scent was up against a wall of competing odors. Trying to hear a footstep was like trying to hear a whisper in a factory. The sensory channel was jammed, and this increased the baseline stress level of every animal in the forest. Chronic stress suppresses the immune system. It impairs growth. It reduces reproductive success. The environment was not just physically hostile. It was psychologically grinding. This leads us to a final, devastating insight. The dinosaurs that lived through the late Cretaceous were not thriving because the world was kind. They were thriving because they had evolved to endure a world that was fundamentally hostile to complex life. They were endurance athletes in an endurance race that had no finish line. And that resilience, that incredible toughness, may have been their undoing. When the asteroid struck, 66 million years ago, it did not hit a robust, healthy planetary ecosystem. It hit a world already under siege, already weakened by millions of years of high oxygen, chronic parasitism, and relentless fire. The dinosaurs had been living on the edge of their physiological tolerance for so long that they had no reserves left. The impact winter, the global darkness, the collapse of the food web, these were the final straws, but they fell on a population already carrying a staggering burden of disease and stress. The asteroid did not destroy a paradise. It finished off a world that was already dying by inches, and this changes everything about how we see the extinction. The disappearance of the dinosaurs was not a sudden catastrophe that erased a perfect world. It was the climax of a long war of attrition, a war the dinosaurs had been fighting since the Triassic. The tiny things had been winning for 100 million years before the rock from space arrived. The asteroid just sealed the victory, and as the impact winter settled over the planet, the last dinosaurs did not die in battle. They died of starvation, exposure, and the final, overwhelming tide of infections that their exhausted immune systems could no longer fight. They died alone, in the dark, and the forest, that beautiful, terrible forest, took their bones and slowly turned them to stone. The story we have told ourselves about the age of dinosaurs is incomplete. It is not a story of invincible giants. It is a story of survival against impossible odds, and of a slow, creeping doom that wore them down from the inside, long before the sky fell. But the asteroid, as catastrophic as it was merely the final punctuation mark on a sentence that had been writing itself for 100 million years. The Cretaceous forest did not just host dinosaurs. It dismantled them, piece by piece, using a strategy so patient and so thorough that it made the T-Rex look like an amateur. To understand the true depth of the horror, you have to look down, past the ferns, past the rotting logs, into the leaf litter itself. Because the real power in this ecosystem was not walking on 4 legs or 2. It was spreading beneath them, a silent, hungry web of filaments that connected every rotting stump and every fallen corpse in a network of relentless, slow-motion predation. We are talking about fungi. In the modern world, fungi are the quiet recyclers, the mushrooms that pop up after rain. But in the Cretaceous, with the humidity locked at 80% and the temperature never dipping below tropical, the fungal kingdom was an empire. Every inch of exposed wood, every discarded scale, every pile of dung was colonized within hours by spores. The forest floor was not a solid surface so much as a living, digesting membrane. Walk across it, and you were walking on millions of miles of microscopic hyphae, the root-like threads of fungi that penetrated every organic substrate and dissolved it from within. The smell of the Cretaceous was not just the sweet rot of decay. It was the metabolic breath of a kingdom that never slept, and it did not stop at the dead. The great innovation of Cretaceous fungi was their willingness to cross the boundary into living tissue. For a dinosaur, any scratch was a potential fungal infection. Any insect bite was a portal. The constant moisture meant that skin, the largest organ and the body's first line of defense, was perpetually compromised. Modern amphibians suffer terribly from chytrid fungus, a disease that attacks keratin and breaks down the skin until the animal cannot breathe or regulate water. In the Cretaceous, 100 million years before the first frog encountered chytrid, similar opportunistic fungi had already learned to exploit the thin, constantly damp skin of dinosaurs. Paleontologists have found fossilized dinosaur bones with lesions that look exactly like the kind of chronic fungal osteomyelitis you see in modern reptiles, kept in overly humid conditions. The bone is pitted, swollen, and deformed, evidence of a long, losing battle against something that did not even have a brain. But wait, it gets worse. The fungal network did not just attack from the outside. It got inside, through the mouth, through the lungs. The same spores that floated in the air and settled on every surface also lodged in the respiratory tracts of every breathing animal. In a high-oxygen environment, lung tissue is already under oxidative stress. Layer on a constant insult of fungal spores, and you have a recipe for chronic respiratory disease. Sauropods, with their impossibly long necks, had to move vast volumes of air through those tracheal tubes just to stay oxygenated. Every breath pulled in a fresh dose of spores. Their lungs, preserved only as impressions in some rare fossils, show evidence of scar tissue, the kind you get from repeated infections. These giants were breathing through a permanent low-grade pneumonia, using lungs that were slowly being colonized by organisms too small to see. And the fungi did not work alone. They were in league with the humidity itself. 80% humidity means that nothing ever really dries. A modern animal with a wound can rely on scabbing, a process that requires drying. But in the Cretaceous, a scab was an invitation. It stayed soft, a perfect culture medium for bacteria and fungi. The wound wept. It oozed. It attracted more flies, which laid eggs, and soon the wound was not just infected but infested, a writhing mass of maggots consuming the dead and living tissue alike. This is not speculation. We find fossilized dinosaur skin with the unmistakable trails of dermastid beetle larvae, the same family of beetles that modern taxidermists use to clean skeletons. The beetles were not eating a dead dinosaur. They were eating a live one, slowly, from the outside in. The great armored Ankylosaurus, with its bony plates and clubbed tail, was a fortress against tooth and claw, but it had no defense against a creature that could slip between the cracks of its armor and turn its own flesh into a nursery. And now we must talk about the wounds themselves, the ones that did not come from predators, but from the environment. The forest was not a smooth, carpeted floor. It was a maze of fallen branches, broken tree trunks, and sharp-edged cycads. A large dinosaur, running from a fire or a predator, risked catastrophic injury with every step. A broken leg was a death sentence, but even a deep puncture wound on the foot could introduce bacteria that caused septic arthritis. In a modern hospital, that is a surgical emergency. In the Cretaceous, it was a slow 6-week countdown to organ failure. The fossilized bones of a Daspletosaurus, a relative of T. rex, show a healed fracture in the fibula, but also signs of a bone infection that nearly killed the animal. The infection was walled off, a chronic abscess that the tyrannosaur carried for years before it finally died of something else. Living with pain was not the exception. It was the standard. But the true genius of the Cretaceous horror was its multidimensionality. You could not solve one problem without inviting another. The same oxygen that fed the wildfires also fed the insects, giving them metabolic energy to breed faster and bite harder. The same humidity that kept the fungi happy also kept the ferns laden with water droplets that hosted leptospirosis-like bacteria. The same giant bodies that made sauropods nearly immune to predation also made them walking islands of parasitic diversity, carrying entire ecosystems of lice, ticks, and worms that had evolved over millions of years to specialize on that single species. It was a trap. Every adaptation that solved one problem created two new ones. Evolution in the Cretaceous was not a ladder. It was a treadmill set to an incline that kept getting steeper. And nobody was running that treadmill harder than the hadrosaurs. The duck-billed dinosaurs are often depicted as the cows of the Cretaceous, placid herd animals munching on leaves. But their jaws, those extraordinary dental batteries of hundreds of tightly packed teeth, tell a different story. They were not chewing soft leaves. They were grinding through grit-laden, silica-rich ferns that wore down teeth faster than any modern herbivore experiences. A hadrosaur's tooth replacement rate was astonishing, a new tooth erupting every few weeks, a conveyor belt of fresh enamel to keep up with the relentless abrasion. Why did they eat such terrible food? Because they had to. The more nutritious plants were either too rare, too toxic, or already claimed by other species. So the hadrosaurs ate the botanical equivalent of sandpaper, and their guts processed it into something resembling energy, but at a cost. Their teeth wore to nubs, their jaws ached, and the constant chewing of tough, fibrous material caused dental abscesses that could spread infection into the jawbone. We find hadrosaur jaws with holes drilled through the bone, draining sinuses from deep infections that would have filled their mouths with the taste of pus. And the hadrosaurs were the success story. They were the ones who figured out how to make a living in an ecosystem designed to break them. But their success made them targets. The sheer density of hadrosaur herds, moving through the forests and along the coastal plains, created a mobile feast for the biting insects. The herd did not just attract predators. It created its own microclimate, a plume of sweat, breath, and shed skin that drifted for miles downwind, drawing mosquitoes and horseflies from across the valley. At night, the herd bedded down in groups for safety, and that safety came with a price. The concentration of large, warm bodies in one place raised the local temperature and humidity even further, creating a hot, damp bubble where parasites could thrive. The ground around a popular nesting site, used for generations, became so saturated with parasite eggs that the very act of being born was a gamble against overwhelming odds. Now, let us descend to the lowest level of this world, to the creatures that lived in the permanent twilight beneath the fronds, the mammals. We have been told that mammals were small, insignificant, rat-like creatures that scurried in the shadows, waiting for the dinosaurs to die so they could inherit the planet. That is a lie of convenience. The mammals of the Cretaceous were not biding their time. They were actively making life miserable for every dinosaur that crossed their path. They did this not through direct combat, but through theft, sabotage, and targeted predation. A mother dinosaur laying eggs in a mound of vegetation was competing with mammals that had already evolved the trick of digging into those mounds and stealing the eggs. The mammals were warm-blooded, fast, and capable of operating at night, when the larger reptiles were sluggish. They could navigate the labyrinth of roots and burrows with a speed no dinosaur could match. They did not just scavenge. They were specialist nest raiders, and in doing so, they applied a constant, nagging pressure on dinosaur reproduction. The snakes were even worse. The Cretaceous saw the rise of true snakes, elongated, limbless reptiles that could slip through the undergrowth without a sound. They had one job: to find the nests, the hatchlings, the unwary, and inject them with a cocktail of enzymes that began digesting them from the inside before they even died. A baby dinosaur, freshly hatched and squawking for its mother, was an ambulatory meal for a snake. The forest floor was a minefield of motionless serpents, coiled and patient, waiting for the patter of tiny feet. And the baby dinosaurs, driven by instinct to scatter and find cover, ran straight into those waiting mouths. But the true apex of the small and the terrible was the combination of the snake and the parasite. Some snakes carried their own parasites. A snakebite might deliver not just venom, but a dose of bacteria so potent that it caused necrosis. Even if the hatchling escaped, it would develop a festering wound that would kill it within days. The survival rate of a dinosaur from egg to adulthood, by some estimates, must have been a fraction of a percent. For every hadrosaur that reached 10 tons, 10,000 never saw their first birthday. The forest was a meat grinder for the young, and it ran on a fuel of infinite remorseless smallness. And then there was the water. In every depiction of dinosaur life, the watering hole is a place of peace, where animals gather to drink in a sort of ancient truce. The reality was more like a medieval battlefield after the fighting is done. The water itself was a biological weapon. Standing pools in the Cretaceous were not clear, fresh springs. They were warm, stagnant, and thick with suspended organic matter. Algal blooms were so common that the water probably tasted of decay and was often toxic. The algae, fueled by the detritus washing in from the surrounding forest, produced cyanotoxins that could damage the liver and nervous system of any animal that drank enough. A thirsty dinosaur, already weakened by parasites and chronic infection, would drink deep, and in doing so, consume a fresh load of protozoan cysts, nematode eggs, and bacteria that caused violent, dehydrating diarrhea. And the water hid more than germs. It hid the crocodilians, enormous aquatic predators that had perfected the art of the ambush. A Dinosuchus, as long as a school bus, lay just beneath the surface, only its eyes and nostrils visible. The ripple of a drinking dinosaur's snout was the dinner bell. The crocodilian would strike with a speed that belied its bulk, clamping down on the muzzle or leg of its prey and dragging it under to drown. The death was not quick. It was a slow, panicked thrashing that churned the water to mud, and then silence, broken only by the bubbles of the last air escaping the lungs. The herd would watch, unable to help, and then they would drink from another spot, because thirst was a more immediate killer than any crocodile. The same water that held the corpse of their herd mate slaked their thirst, and the cycle of contamination continued. And yet, even in the face of all this, the dinosaurs persisted. They sang their low-frequency songs through the foggy mornings. They defended their nests with a ferocity that left the bones of predators scattered around the perimeters. They raised their young, sometimes for years, teaching them the safe paths, the edible plants, the warning calls. But this is where the story takes its darkest turn, because the very behaviors that allowed dinosaurs to survive also kept them trapped in the cycle of attrition. The herd loyalty that gave them safety in numbers also concentrated them for parasites. The nesting fidelity that returned them to the same breeding grounds each year also kept those grounds permanently contaminated. The giant body size that deterred predators also required a lifetime of eating low-quality food, slowly poisoning themselves with plant toxins. There was no way out. The Cretaceous forest was not just a place. It was a problem with no solution. And now we must confront the most difficult truth of all. The dinosaurs were not ignorant victims of a cruel world. They were participants in their own slow destruction. Their evolution, the very traits we admire, their size, their armor, their elaborate social structures, were all responses to a world that demanded more and more just to stay in place. The Cretaceous was an evolutionary arms race against an enemy that could not be seen, and every weapon the dinosaurs developed had a recoil. The larger they grew, the more food they needed, and the more they exposed themselves to the toxins and parasites of the forest. The more social they became, the more efficiently disease spread. The more they invested in their young, the more crushing each loss became, until the psychological toll of survival was as heavy as the physical one. The fossil record does not preserve tears, but it does preserve stress lines in bones, evidence of interrupted growth, of years where the animal nearly starved, of seasons of suffering that left their mark on the very skeleton. These were not dumb brutes. They were creatures that experienced fear, pain, and exhaustion, and they experienced them for their entire lives. And it all came down to one final, terrible irony. The high oxygen that fueled the fires, the size, the insect swarms, was also the thing that allowed the dinosaurs to evolve in the first place. The Triassic and Jurassic periods had the same high oxygen, the same rampant parasites, the same fires. But by the late Cretaceous, the system had been running for so long that the parasites had become more specialized, the fungi more aggressive, the plants more toxic. The world was not static. It was evolving against the dinosaurs, getting better at killing them with every passing millennium. The dinosaurs were not declining in some passive sense. They were being actively, systematically hunted by the ecosystem itself. The asteroid, when it came, did not strike a world at its peak. It struck a world at the end of a long, slow siege, a world where the defenders were already exhausted, already wounded, already fighting a dozen invisible enemies that had been winning for millions of years. And that is the story we have been missing. Not of giants brought low by a rock from space, but of 100-million-year war of attrition fought in the blood and the guts and the lungs of every living thing. The dinosaurs were the greatest survivors Earth has ever produced, not because the world was kind to them, but because it was relentlessly, creatively, exhaustingly cruel. And they endured it. They endured it until the very elements turned against them, and even then, some of them, the ones we now call birds, squeezed through the bottleneck and survived to sing in the trees we walk under today. But that survival came at a cost. The birds are small, fast, and light, not because they wanted to be, but because every ounce of dinosaur that could not fly, that could not flee, that could not hide from the tiny, swarming, biting, infecting hordes was eventually pruned from the tree of life. The Cretaceous forest did not just kill dinosaurs. It sculpted the survivors into something entirely new. And the world that emerged from the ashes of the impact was a world where the tiny things had finally, unequivocally won. The asteroid did not end the Cretaceous. It simply drew the curtain on an act that had already run far past its climax. When the rock struck the Yucatan 66 million years ago, the world it hit was already a hospital ward, full of patients managing chronic conditions they would never recover from. The impact winter, the darkness, the acid rain, these were the mercy stroke, not the opening salvo. And the real story is not what died in those first terrible months. It is what survived, and how the horrors of the Cretaceous shaped every living thing that came after. In the immediate aftermath, the global temperature dropped by perhaps 10 degrees Celsius. Photosynthesis shut down. The marine plankton that formed the base of the ocean food web vanished, and the forests, already battered by centuries of fire and insect infestation, began to collapse. Large herbivores starved. The sauropods, those immense long-necked browsers that had endured so much, simply ran out of food. Their gigantic bodies required colossal amounts of energy, and when the ferns and conifers stopped growing, the sauropods had no reserves left. They died where they stood, their bones weathering in the dim twilight for years, picked clean by scavengers that were themselves starving. The tyrannosaurs, apex predators of the inland landscapes, faced a similar fate. They had fed on the living, but the living were gone. The last of the great theropods likely wandered through ash-filled forests, hunting for anything that still moved, and found only silence. But the small things, the creatures that had lived in the cracks and crevices of the Mesozoic world, did not all die. The mammals, those nest-raiding, insect-eating survivors of the ancient darkness, had a crucial advantage. They were small enough to hide in burrows and survive on seeds, insects, and carrion. They had fur, which insulated them from the cold, and a high metabolism that could sustain activity when the sun was not shining. They had spent 100 million years being bullied, bitten, parasitized, and hunted, and that experience had shaped them into resilient, adaptable generalists. The asteroid did not kill them because they had already been living in a world that was trying to kill them every day. The same pressures that made the Cretaceous a nightmare for dinosaurs were the pressures that forged the mammalian toolkit. And the birds are the living dinosaurs that made it through. Their ancestors, the Maniraptoran theropods, had already evolved feathers, a high metabolic rate, and the ability to fly. Feathers, it turns out, were not just for flight. They were a barrier against biting insects, a layer of insulation that reduced the energy cost of staying warm, and a tool for social signaling that allowed complex flock behaviors. The same feathers that kept parasites off their skin also kept the ash and cold off their bodies. The birds that survived the impact were small, seed-eating species that could find sustenance in the charred landscape. They carried with them the genetic memory of the Cretaceous horrors, encoded in their immune systems, their grooming behaviors, and their instinctive fear of open water and dark undergrowth. Every bird you see today, from the humble sparrow to the soaring eagle, is a survivor of that ancient, grinding war, sculpted by 100 million years of invertebrate predation. But the legacy of the Cretaceous is not just in the survivors. It is written directly into our own bodies. The diseases that plagued the dinosaurs did not vanish with their hosts. They adapted, jumped to new vectors, and continued their ancient work. Leishmania, the same protozoan parasite that infected Cretaceous reptiles via sandfly bites, still infects humans today, causing a spectrum of disease from disfiguring skin ulcers to fatal organ damage. The malaria organisms that swarmed in the guts of Cretaceous-biting midges have descendants that infect hundreds of millions of people every year. The roundworms and flatworms that crowded dinosaur intestines belong to the same families that plague livestock and children in tropical regions. The Cretaceous forest is not a distant memory. Its parasites are still with us, still using the same biochemical tricks to evade our immune systems, still causing untold suffering in the warmer, wetter parts of our modern world. And the fungal spores that colonized dinosaur lungs have not gone anywhere. In the aftermath of the asteroid, the global darkness and cold created a temporary fungal bloom. The massive die-off of plants and animals provided a banquet of dead organic matter, and the fungi inherited the earth for a brief, spectacular moment. The fungal hyphae that had been slowly digesting the forest floor spread unchecked, breaking down the corpses of the Cretaceous world and returning their nutrients to the soil. That fungal explosion created the first rich, thick soil layers that would later support the expansion of grasslands and the rise of mammalian megafauna. The very ground beneath our feet is, in part, the processed remains of the Cretaceous, run through the digestive system of a billion fungi. But the most profound legacy of the Cretaceous is invisible. It is in the oxygen we breathe. The high oxygen world of the Mesozoic was a rare and dangerous experiment. The fires, the oxidative stress, the gigantic insects, these were all consequences of an atmosphere that had tipped out of balance. The charcoal layers in the fossil record tell us that the high-fire world of the Cretaceous slowly drew down oxygen levels, as the carbon from burned forests was buried in sediments and the oxygen was consumed by weathering rocks and decomposing organic matter. By the time the asteroid struck, oxygen had probably already begun to decline from its peak. The impact accelerated that process, but the long-term trend was toward a more stable, lower oxygen atmosphere. Our modern 21% is not a default state. It is a hard-won equilibrium, a safety valve that prevents the kind of global firestorms that tormented the dinosaurs. Every breath you take of this relatively mild air is a reminder that the Earth has learned, over hundreds of millions of years, to tame its own excesses. And now, the final surprising detail, the one that ties all of this together. The Cretaceous forest did not just shape the animals that lived in it. It shaped the animals that would come millions of years later by creating the conditions for their evolution. The constant pressure of parasites and pathogens drove the evolution of complex immune systems the adaptive immunity that allows our bodies to recognize and remember specific invaders. The dinosaurs had a version of this, but the mammals and birds refined it, building on the foundation of suffering laid down in the Mesozoic. The hot, humid, fever-inducing infections of the Cretaceous selected for individuals who could raise their body temperatures to fight off pathogens, cementing the high metabolic rates that define modern mammals and birds. Your ability to run a fever, to produce antibodies, to inflame a wound and wall it off, these are direct inheritances from the ancient war against the tiny things. You are the product of a billion generations of animals who survived, just barely, long enough to reproduce, and the scars of that struggle are written into your DNA. The Cretaceous was not a paradise. It was a beautiful, terrifying, exhausting place to be alive. But it was also a forge. It burned away the weak and the slow, and from the ashes emerged the blueprint for the modern world. The dinosaurs, in their suffering, paid the price for our existence. The forest that tried to kill them gave us the immune system that protects us. The parasites that drained their blood taught our ancestors how to fight back. The nightmare of the Cretaceous is the reason you are here tonight, breathing easy, safe from the swarms, listening to a story about a time when life was harder than you can possibly imagine. And if you step outside tomorrow and see a bird, or a mammal, or even a mosquito, remember, they carry the Cretaceous inside them, a living memory of a world that was both cradle and crucible. The forest never truly died. It just changed shape, and it is still watching, still waiting, in the wet, warm corners of the world for the next chance to reclaim what was once its own. And so we arrive at the end of the Cretaceous, but not the end of the story. The forest that once stretched unbroken from the equator to the poles has long since vanished, buried under miles of sediment, compressed into coal and oil and stone. But its fingerprints are everywhere. Every time you walk through a patch of old-growth woodland and feel that sudden primal prickle at the back of your neck, you are feeling the ghost of the Cretaceous. Every mosquito that whines in your ear at dusk is a living echo of the swarms that drained the blood of titanosaurs. Every fungal infection that stubbornly resists treatment is using biochemical strategies first refined in the damp, dark understory 100 million years ago. The world you live in was built on the bones of that ancient, beautiful nightmare, and you carry its memory in ways you are only beginning to understand. This is the part of paleontology that rarely makes it into the documentaries. We love the spectacle, the teeth, the thunderous footfalls. We love to imagine the Tyrannosaurus as the undisputed king of its domain, the Triceratops as an immovable fortress, the sauropods as serene gods walking through a green and gentle world. But the real power, the real shaping force of the Mesozoic was always the tiny, the numerous, the hidden. The parasites that rode inside every dinosaur, the insects that drank from them, the fungi that digested them while they still walked, the fires that reshaped the landscape in a single afternoon. These were the authors of the Cretaceous. The dinosaurs were merely the protagonists, and in the end, they were not even the survivors. They were the stage on which the microscopic drama of life played out, and that drama has never truly stopped. There is a philosophical weight to this that settles on you the more you think about it. We construct our own world with the same blind confidence the dinosaurs must have felt. We build cities, cure diseases, stare down the largest predators that walk the planet, and we tell ourselves that we are in control. But the oak tree growing in the park still pumps tannins into its leaves to ward off insects that have been chewing on plants since the Carboniferous. The bacteria in the soil still break down the dead into nutrients using pathways that were ancient before the first dinosaur took a breath. The mosquito breeding in the old tire in your backyard is using the same chemical receptors to find your blood that its ancestors used to find the blood of an iguanodon. We are not separate from the Cretaceous story. We are its latest chapter, and the same forces that shaped the dinosaurs are still shaping us, silently, constantly, whether we acknowledge them or not. And here is the thing that keeps me up at night, the slow, unsettling realization that the Cretaceous never truly ended. The extinction event that wiped out the non-avian dinosaurs was a brutal filter, not a reset. It cleared the stage for the mammals and the birds, yes, but it did not erase the underlying architecture of the world. The atmosphere we breathe today is a direct descendant of the Cretaceous atmosphere, chemically altered by the fires and the forests and the slow march of evolution. The soil under our feet is Cretaceous soil, enriched by the decomposed bodies of 1 trillion creatures. The diseases we fight, the parasites we dread, the fungal spores that drift in the humid summer air, these are not new inventions. They are ancient lineages that have outlasted every single species that ever tried to dominate the planet. The age of dinosaurs is not a closed chapter. It is a buried foundation, and everything we are stands on top of it. When you walk through a tropical greenhouse, the kind with towering ferns and dripping leaves and air so thick you can taste it, you are walking through a fragment of the Cretaceous. Your lungs adjust to the humidity, your skin begins to prickle with sweat, and somewhere in the back of your brain, a very old part of your nervous system recognizes this place. It is not a conscious recognition. It is deeper than that, buried in the genetic memory of 100 million years of mammalian survival. Your ancestors lived in this kind of environment, and they survived it by being small, fast, and clever. They watched the dinosaurs die, generation after generation, from infections that would not heal, from parasites that stole their strength, from fires that left nothing but ash. And they learned, in their small mammalian way, that the world was not a gentle provider. It was a constant, grinding test, and the only way to pass was to endure. That endurance is your inheritance. Your immune system, with its bewildering complexity of antibodies and T cells and inflammatory cascades, is a direct product of the Cretaceous arms race. Every time you fight off a cold, every time a cut heals without becoming infected, you are using tools that were forged in the bodies of animals who bled and ached and died in the shadow of the dinosaurs. The fever response, that uncomfortable heat that leaves you shivering under blankets, is a weapon borrowed from the Mesozoic, a way to raise your body temperature beyond the tolerance of invading pathogens. The dinosaurs likely did the same, but they did it in bodies so large that fever alone could not save them. You, small and furred and warm, are the beneficiary of 1 billion evolutionary experiments, most of which ended in death. The Cretaceous is not just a distant epoch. It is a continuous event, still unfolding in your bloodstream, still shaping the way you live and die. And the forest itself, that dark, consuming presence that we have spent these hours exploring, has left its mark on your mind. The fear of the dark, the unease you feel when you hear an unexplained rustle in the undergrowth, the primal startle response to a sudden buzzing near your ear, these are not irrational phobias. They are the distilled wisdom of your evolutionary history, warnings passed down from ancestors who learned that the shadows contained real threats. The Cretaceous forest was a place where the wrong step could mean a fungal infection that would kill you in weeks, where the wrong bite could introduce a parasite that would haunt you for years, where the wrong drink could fill your guts with organisms that would drain you dry. The animals that survived that world passed on their caution, their vigilance, their tendency to assume the worst when the light grew dim and the air grew heavy. You are the descendant of the paranoid, the anxious, the ones who never quite relaxed. And that is why you are here tonight, listening to a story about a time when relaxation was a death sentence. So, what do we do with this knowledge? What does it change? To know that the Cretaceous was not a paradise but a beautiful, terrifying, exhausting place to be alive. I think it changes the way we see our own world. It strips away the romantic veil we have draped over the natural world, revealing the struggle that has always been there. The robin singing on your windowsill is not a symbol of gentle spring. It is a survivor, the descendant of dinosaurs who ran through fire and flew through ash, who carried parasites and fought infections and somehow, against all odds, lived long enough to raise their young. The mosquito that bites you on a summer evening is not an annoyance. It is an ancient enemy, the descendant of insects that bit Tyrannosaurus, that carried the pathogens that shaped the entire arc of vertebrate evolution. The fungus that sprouts on a fallen log after a rainstorm is the same kingdom that once digested the Cretaceous from the inside out, and it has not forgotten how. There is a kind of liberation in this perspective. Once you see the world as it has always been, a constant negotiation between life and the forces that would extinguish it, you stop expecting it to be kind. You stop expecting the past to be a gentle, golden age, and you start seeing it for what it was. A time of incredible beauty and unimaginable hardship, a time when every sunrise was a minor miracle, a time when the giants walked, not because the world was easy, but because they were too stubborn to stop. The dinosaurs were not victims of a cruel fate. They were participants in a story that had no heroes and no villains, only survivors and the forces that shaped them. And that story is still being told, in the birds that fly overhead, in the parasites that still trouble us, in the fungi that still recycle the dead, in the fire that still sweeps through dry forests, and in the air we breathe, which still carries the ghost of the Cretaceous in every molecule. As you drift off tonight, I want you to think about that ancient forest, not as a lost world, but as a presence that has never truly left. The same stars that shone down on the Cretaceous shine down on you. The same moon that lit the nesting grounds of hadrosaurs lights your window. The same humid air that fed the fungi and the biting flies still fills the tropical forests of the modern world, and somewhere in those forests the old story is still playing out. The same battles, the same suffering, the same stubborn, relentless persistence of life. The Cretaceous is not a chapter in a book you can close. It is a thread that runs through everything you are, everything you see, everything you fear, and everything you love. And the more you pull on that thread, the more the whole tapestry of life on Earth unravels into a single, astonishing, terrifying truth. We have never left the forest. We just learned to forget. If you found yourself captivated by this journey into the dark side of the Cretaceous, do what the dinosaurs could not. Press that subscribe button, secure your survival, and drop a comment telling me where you are listening from and what time it is for you. This channel is dedicated to uncovering the hidden stories that history forgot, the uncomfortable truths that lie beneath the surface of our comfortable world. Every week, we slip into another corner of the past, and I would love to have you along for the ride. Until next time, rest well, and remember, the forest is still there, waiting in the warm, wet corners of your dreams.